Imagine you are walking along a riverbed somewhere in ancient India, maybe 2,500 years ago. You reach down and pick up a stone. It is clear. It catches the light in a way that stops you completely. You turn it over in your hand, and it throws tiny rainbows across your palm. You have never seen anything like it. You do not know what it is. You do not know that this small, unremarkable pebble will one day become the most coveted object in human history. That is how the story of diamond begins. Not in a laboratory, not with a scientist, with a person, a riverbed, and a rock that looked different from every other rock. But here is the question that almost nobody asks. How did ancient people figure out what a diamond actually was? How did they separate it from the thousands of other shiny, clear, and glittering stones scattered across the ancient world? And once they found it, how did they figure out what to do with it, given that diamond is the hardest natural material on Earth and cannot be cut, scratched, or shaped by any ordinary tool? The answers pull you into one of the strangest and most underappreciated detective stories in human history. To understand how diamond was discovered, you need to understand what the ancient world looked like before it. For most of human history, the stones that people valued were colored stones. Lapis lazuli, the deep blue stone traded across the ancient Near East for thousands of years. Carnelian, the reddish-orange stone used for beads and seals in Egypt and Mesopotamia. Turquoise, garnet, amethyst. These were the precious materials. They had color, they had presence, they communicated wealth and status immediately and visually. A raw diamond does not do any of that. A rough, uncut diamond pulled from a riverbed looks almost nothing like the brilliant, sparkling gems you see in a jewelry store today. It is typically pale, yellowish, or even brownish. Its surface is not smooth and glassy. It is often waxy, greasy-looking, with a texture that mineralogists describe as adamantine, which is a technical way of saying it has a very specific kind of luster that is neither metallic nor glassy, but something in between. A rough diamond can look, to an untrained eye, like a particularly dull piece of quartz. So why did ancient people pick them up at all? The answer almost certainly comes down to weight and feel. Diamond is significantly denser than most common minerals. A diamond the size of a small pebble is noticeably heavier than a quartz crystal of the same size. People who spent their lives handling stones, sorting river gravels, trading gemstones, they developed an instinct for density. Something that felt wrong, too heavy for its size, got a second look. And then there was the luster. Even uncut and unpolished, a diamond has a surface quality that is subtly different from quartz or glass or rock crystal. Under bright sunlight, it catches light in a way that is almost oily, almost alive. It is not spectacular. It is not immediately obvious, but it is different enough that a careful, experienced eye notices it. The earliest written records of diamond come from India, specifically from Sanskrit texts dating to somewhere around the 4th century before the Common Era, though the stone itself was almost certainly known and traded for centuries before anyone wrote about it. The Sanskrit word was vajra, which also meant thunderbolt, and later the word hiraka appeared, which became the root of the modern Hindi word hira, meaning diamond. The connection to thunderbolt was not accidental or poetic. Ancient Indians believed diamonds formed where lightning struck the earth. The hardness, the brilliance, the sense that this stone was somehow more than a stone, all of it pointed towards something divine, something celestial. This pattern, where ancient cultures independently reach for sky and heaven to explain diamond, mirrors almost exactly what happened with meteoritic iron. When ancient people encountered a material that behaved unlike anything else in their experience, their instinct was to place its origin outside the natural world. Diamond was too hard to be ordinary earth. It had to come from somewhere else. The place where diamonds were first found in significant quantities was the river systems of what is now the Indian subcontinent, particularly in the regions of Golconda in modern Andhra Pradesh and along the rivers of central India. These were alluvial deposits, meaning diamonds that had been eroded out of their original host rock over millions of years and carried downstream by rivers, where they settled in gravel beds alongside other heavy minerals. For the people who worked these rivers, diamond was not the primary target at first. They were sorting river gravels for gold, for garnets, for other heavy minerals that had commercial value. Diamond came up in the process. It was a bycatch of a different industry. And at first, it was probably not even recognized as a distinct material. It was just another strange, heavy, clear stone that occasionally turned up in the gravel. The recognition that this particular clear stone was fundamentally different from all other clear stones came slowly, through accumulation of experience, and the property that made diamond unmistakable, once you knew to test for it, was hardness. Ancient people tested stones by scratching them against each other. This was practical, everyday knowledge for anyone who worked with minerals. You learned quickly which stones scratched which. Quartz scratched softer stones. Corundum scratched quartz. But diamonds scratched everything. There was no other stone in the ancient world that could leave a mark on diamond. Everything else, when dragged across a diamond surface, left the mark on itself. This was not a subtle difference. It was an absolute one, and once a person experienced it, they understood immediately that they were dealing with something categorically different from every other material they had ever encountered. The ancient Sanskrit texts describe this property explicitly. The Arthashastra, an ancient Indian treatise on statecraft and economics traditionally attributed to the scholar Kautilya and dating to roughly the 4th century before the Common Era, contains a remarkably detailed section on gemstones that includes specific tests for identifying genuine diamonds. It describes testing hardness by attempting to scratch the stone with other minerals. It describes the weight, the luster, and the way genuine diamonds interact with light. This was not casual observation. This was systematic knowledge developed over generations of trade and handling. The Arthashastra also describes diamond quality in terms that map surprisingly well onto the modern grading system. It distinguishes between diamonds of different colors, different degrees of clarity, different sizes. It categorizes them by origin, noting that stones from different river systems had different characteristic qualities. This level of classification does not emerge overnight. It represents centuries of accumulated commercial knowledge. But here is where the story gets genuinely strange. Ancient people could identify diamonds. They could classify them. They could trade them across enormous distances. The Arthashastra mentions diamond as a commodity in long-distance trade, and we know from archaeological evidence that Indian diamonds were reaching the Mediterranean world by at least the 1st century of the Common Era, probably earlier. What they could not do was cut them. This is the paradox at the heart of early diamond history. The property that made diamond extraordinary, its absolute hardness, was also the property that made it completely impossible to work with using any tool available in the ancient world. You cannot cut diamond with iron. You cannot grind it with sandstone. You cannot shape it with copper or bronze. The only material hard enough to scratch diamond is diamond itself. So for most of ancient history, diamonds were used not as cut gems but as objects in their natural form. They were set into jewelry as rough crystals. They were worn as talismans. The natural octahedral crystal shape of diamond, which looks like 2 pyramids joined at the base, was considered beautiful in itself and required no modification. There was also a different kind of use that is far less glamorous but arguably more historically significant. Diamond as a tool. Ancient craftsmen in India discovered, probably through accident, that diamond fragments could scratch and abrade materials that nothing else could touch. A small piece of diamond embedded in a stick or held in a hand tool could be used to engrave designs into hardstone seals, into gems, into surfaces that would defeat any other abrasive. Diamond dust, the fine powder produced when diamonds fractured or were crushed, could be used as an abrasive paste to polish hard gemstones to a degree of smoothness impossible to achieve any other way. This industrial use of diamond almost certainly predates its use as a gemstone. The people who first recognized diamonds' unique properties were not jewelers. They were craftsmen working with hard materials who needed something harder than everything else. Diamond was a tool before it was an ornament. The knowledge of how to use diamond dust as an abrasive is what eventually unlocked the gemstone's potential. Because if you can use diamond dust to polish other stones, you can, in principle, use diamond dust to polish diamond itself. And once you can polish diamond, you can begin to shape it. The earliest evidence of deliberately cut and polished diamonds dates to somewhere around the 1st century of the Common Era in India. These were not the complex, multifaceted cuts of later centuries. They were simple polished points and flat surfaces, taking advantage of the natural crystal planes of diamond, the directions along which the crystal structure is slightly weaker and can be cleaved with a careful, well-placed blow. Diamond has a property called cleavage, which means that along certain precise directions determined by its crystal structure, it can be split relatively cleanly with a sharp impact. This is deeply counterintuitive. The hardest natural material on Earth can be split, not easily, not safely, and with enormous risk of simply shattering the stone entirely, but it can be done. An ancient Indian craftsman figured this out. How they figured it out is itself a remarkable story of observation. Diamond crystals found in river gravels are sometimes naturally cleaved, broken along their crystal planes by the mechanical stresses of being tumbled and transported downstream. A craftsman examining a collection of rough diamonds would have noticed that certain fracture surfaces were flat and smooth in a way that random fracture surfaces are not. they would have noticed that these flat surfaces occurred in consistent orientations relative to the crystal shape. The leap from observing natural cleavage to deliberately inducing it was not a small one. It required understanding that the flat surfaces were not random, that they followed a rule, and that the rule could be exploited. It required developing tools, a sharp iron blade and a mallet, and a technique for placing the blade precisely on the crystal surface and delivering a controlled blow. And it required accepting a very high failure rate, because a miscalculated blow does not produce a clean cleavage. It shatters the diamond into fragments. This knowledge was extraordinarily valuable and was kept as closely guarded trade knowledge within specific communities of craftsmen. In India, the working of diamonds and precious stones was a hereditary craft passed from parent to child within specific castes and communities. The technical knowledge did not circulate freely. It was protected because it represented a significant commercial advantage. The transmission of diamond knowledge from India to the wider world followed the same routes as the stones themselves: overland through the trade networks of Central Asia, by sea through the Persian Gulf and the Red Sea to the Mediterranean. Roman writers of the 1st and 2nd centuries of the Common Era described diamond with a mixture of accurate observation and spectacular mythology. Pliny the Elder, writing in his Natural History around 77 of the Common Era, gives a description of diamond that contains real technical knowledge buried inside layers of legend. He correctly identifies that diamond is the hardest substance known. He correctly notes that it can only be worked with its own material. He describes the crystal shapes accurately enough that modern mineralogists can recognize what he is describing, but he also repeats stories that diamond can be shattered by soaking it in fresh goat blood, or that it is found only in the nests of eagles who use it to line their nests against snakes. This mixture of accurate observation and wild mythology is exactly what you would expect from a writer who is working at the far end of a long chain of transmission, receiving knowledge that began as practical craft expertise and has passed through many hands and many languages before reaching him. The technical core survived. The context that would allow someone to evaluate which parts were accurate did not. What is striking about Pliny's account is how clearly it shows that the Romans knew diamond was special, knew it was uniquely hard, and knew it came from India, but had essentially no access to the stones themselves. Diamond was so rare in the Roman world that Pliny seems never to have actually held one. He is describing something he has heard about but not touched: the journey from that first person on an Indian riverbed who picked up a heavy, greasy-looking pebble and felt that something was different, to the systematic classification of the Arthashastra, to the first deliberate cleaving of a crystal, to the slow transmission of knowledge westward along trade routes, covers at least 1,000 years of accumulated human observation. And none of it happened because someone sat down and decided to discover diamond. It happened the way almost all ancient discovery happened: through attention, through the habit of noticing when something does not behave the way it should, through the willingness to test, to scratch, to weigh, to compare, and to remember what you found. The person who first recognized that a particular clear pebble was heavier than it should be and set it aside to look at more carefully was not a scientist. They had no framework for what they were doing. They were just paying attention, and that attention, passed forward through generations of craftsmen, traders, and observers, eventually produced one of the most complete and sophisticated bodies of material knowledge in the ancient world. Diamond did not reveal itself. It was found, slowly, by people who were paying close enough attention to notice that something was different, and curious enough to keep asking why.